Today we're going to be doing lesson 32-2 on page 449 in your book. So please get out your book, open it to page 449. We've got some math terms. Let's talk about the math terms first. So if you look in the margins here, it starts with positive association. So these are all describing the association between two variables in a scatter plot. Oops, two variables in a scatter plot, right? So the two variables could have a positive association, and positive association is really close to positive slope. So a positive association, it's not a straight line, so we don't use the word slope, but you could think of it kind of in the same way. So when when one variable is increasing, the other variable is also increasing. And we have an example right here of a positive association. So if I start here, where my x variable is low, I see my y variable is also low. So these points, when x is low, y is low. And then as x increases, y is increasing, right? So these points have a bigger x, but they also have a bigger y. And then as I keep going, as x is increasing, y continues to increase. These points that have the biggest x also have the biggest y. So we would call this a positive association. And if we drew a trend line through this data, find my ruler here, a trend line going right through the middle of the data, same number of points, above the line is below the line, that trend line would have a positive slope if the scatter plot has a positive association. Okay? The next one is a negative association. When the values for one variable tend to decrease as the values for another variable increase. An increase in x corresponds with a decrease in y. So let's look at our example on that one. So here's our negative association. If I start here with the x values very low, the y values are already very high, right? So when x is low, y is high. As x is increasing, y is coming down. My middle set of points, x is getting bigger, but y is getting smaller. And then my last set of points, when x is the biggest, y is the smallest. So these points have a negative association. And a trend line, if I drew a trend line through this data, right through the middle, same number of points above and below the line, not necessarily trying to connect any line points at all, I can see that trend line has a negative slope. All right, and then we have no association at all. As x is small, y is both small and large, right? In the middle, as x is getting bigger, y is still both small and large. And at the end, when x is the biggest it's going to get, y is still small and large. There's no association here. We're not going to try and draw a trend line because I could draw it here, or here, or here, and I'd still have the same number of data points on both sides of that line. So this has no association at all. There's also form. So this is type of association. We call it the direction. So the direction of the association can be positive, negative, or no association. And then we have the form of the association. So the form indicates whether it's linear or non-linear. So let's look at these examples at the bottom here. These points don't all fall in a straight line, but they have a linear trend. If I draw a trend line through these points, I've got about the same number of points above and below. I don't have a big group of points hanging out on one side or the other. So we would say this has a linear association because these points basically scatter about a straight line. We could also say it's a positive association because as x is increasing, y is also increasing. Here we have a nonlinear association. If I try and draw a straight line through these points, I end up with this unsightly bulge of points off on one side of my line. right? And I could try moving the line, maybe here, whoops. But I still have a whole bunch of points that are hanging out on one side that aren't balanced by points on the other. So this is an example of a non-linear scatter plot. These points really follow each other. It's usually not this obvious. We pretty much assume it's linear unless it's clearly non-linear. So if you're not sure, then go with linear. You got to be pretty sure to pick non-linear. Okay, so then we have, so let's recap. We had direction, positive, negative, or no association. We had form. So you could have positive and have it be linear, like this guy. You could have a positive association and have it be non-linear. This guy is positive, but he's not linear. You could have a negative association and have it be either linear or non-linear. Okay? And then our last category is strength. And strength is basically how obvious it is. That is either positive or negative or linear or non-linear. So these two examples that we looked at are both very strong. Because this one is pretty darn obviously positive and linear, and this one is incredibly obvious that it is positive and that it is nonlinear. And then we get to something like this. Would you say this is, well, the answer's down there, but could you say that this is no association at all? They're pretty spread out. But if I look here where x is small, I see the points for y are higher up than if I move down here as x is getting bigger. The points are definitely lower. So there is an association, but it's either, I wouldn't even say moderate. I'd say it's fairly weak. It's a fairly weak association. And now here, could you put a curved line through this data? You could. Could you put a straight line through this data? Well, the weaker the association is, the harder it is to tell whether it is linear or nonlinear. And remember I said, if you're not positive that it's nonlinear, we're going to pick linear. So this one we're going to say has a negative linear association that is fairly weak because we had a hard time deciding whether it was linear or nonlinear. All right, next page. The other thing I need you to keep an eye out for is special characteristics. So there are two special characteristics that you might see. One is an outlier. So here we have our scatter plot. I would say it's linear. So the form is linear. These points are basically following a straight line. I would say the association is positive. As x is increasing, y is also increasing. And I would say it's pretty darn strong. This looks really good. And then you've got this point. Should we try and say, well, it's nonlinear then? Should we bend our line to accommodate this point? Not for one point. We're just not going to do that. Because a lot of times the reason this point is so far away from all the other data is because we made a mistake. Maybe when someone was collecting the information, they wrote it down wrong. And sometimes you just have an oddball who doesn't follow the trend, but we're not going to change our whole association determination just because of one point. So if you have just one point and it's way out from the others, we call that an outlier because it lies outside of most of the rest of the points. Okay? And then the other special category that we might have is a cluster. So here, there is a positive association. Definitely here, where the x values are low, the y values are low. And here, when the x values get bigger, the y values get bigger. But there's no values in between. That space is empty. So we're going to say that that means that we'll just call it a cluster. And a cluster means you've got some more research to do. Why do you have this jump with no data in between? Maybe your sample was bad, right? Maybe you weren't being very random in your sample, or maybe there's something else to study here, but it's something that we want to be aware of, and we would call this clusters of points. All right, thank you very much.